Okay, now sometimes, excuse me, sometimes the easiest way to show that something's not continuous is to show that the output doesn't exist here. So we're going to check that like weird point is at x equals 0. And so if you do g of 0 is 2 over e to the 0 minus 1, you really want to know that that's 1, and that's 2 over 1 minus 1, which is 2 over 0. So g of 0 does not exist, and that means g is not continuous at x equals 0. Okay, so this is going to be a little different. So this is going to be a vertical asymptote, because when you did this function, you get a fixed number and you're dividing by 0. So that's going to tell you that you have this explosive behavior, and that's going to give you a vertical asymptote. They don't ask you too much sometimes to use limit notation for that, because you have to be careful when you come from each side, but you want to know that a fixed number over 0, that is going to explode up or down. And so we're going to go through in a little bit this cool kind of limit flowchart thing, which I found, which I think is super neat. Okay, now let's talk about the end behavior. So that's the limit as x goes to infinity of the function. And you have to be careful. In pre-calc, you guys really only looked at rational functions, and they behave the same in both directions. But we're not going to do exactly the same thing again. So let's think about this. And you really don't want to put anything sort of in the side. I'm going to write in the side. So if you thought about infinity, okay, 2, that's some giant number. You would have e to some giant number minus 1. This is huge. This is huge. So if the denominator is going to infinity, and this is a number, that's going to go to 0. You totally want to know that. Okay. Now if I came from the other direction, you would have 2 e to the negative infinity minus 1. Now hopefully you remember the graph of e. That looks like this. And so when you're going to negative infinity, this is essentially 1. Okay. And so you are going to go 2, and that's going to be, oh, sorry, that's going to 0. It's going to 0 here. So you have 0 minus 1, and this would be 2 over negative 1, which is negative 2. So you have 2 horizontal asymptotes, because these are both constants. This one gives you y equals 0, and this one gives you y equals negative 2. And I am going to go on decimals real quick, and I'll show you what it looks like. I'm just going to graph it. And graph f of x is equal to 2 over e to the x minus 1. You can see this way, it's leveling out at 0. And this way, can you see it's leveling out at negative 2. But the thing is, they won't ask you those questions with a calculator. So you really need to know that you have to use this limit definition. End behavior, horizontal asymptotes. Let's go with these limit behaviors. All right?